Okay, here we have two forces P and Q acting on a particle as shown. P has the magnitude of 10 newtons, Q has a magnitude of 8 newtons. Work out the magnitude and direction of the resultant force. Magnitude means the size, and of course direction means direction, so we want to find out how strong and in what direction is the overall effect of these two forces when you combine them together. So to do that, we're going to work out the horizontal and vertical components of both P and Q. So I'm going to introduce an x-axis and a y-axis onto my diagram. So there we go, x and y axes now on the diagram. That just makes it easier to refer to horizontal and vertical components. So let's first of all work out the horizontal component of both forces. I'm going to call it F subscript x. So the horizontal component of the 10 Newton force is 10 cos 45 degrees. The direction that we are currently working in is adjacent to the 45 degree angle. If it's adjacent, then use cos, otherwise use sine. That's another way of doing these components. If the direction we're working in is adjacent to the angle, then it's cos, otherwise use sine. Now the 8 Newton force, its horizontal component will be 8 cos 30. Again, the 30 is adjacent to the direction, so 8 cos 30. It's positive, so we need a plus. Now 45 and 30 are both common angles, so we're going to simplify them. Cos 45 is root 2 over 2, so that becomes 5 root 2, and cos 30 is root 3 over 2, so that becomes 4 root 3. So that's the horizontal component of the resultant. Let's now do the vertical component of the resultant. Notation I'm going to use is Fy. So just to reiterate, this is the vertical component of both forces P and Q. Let's do P first. So the vertical component of P is going to be 10. Now I'm going to use the way of thinking about it I said about a minute ago. If the angle is adjacent to the direction that we're currently looking at, then use cos, otherwise use sine. So this 45 degree angle here is not adjacent to the vertical. If you want to, you could draw this on. That's now also vertical, and that's opposite the angle. So for those two reasons, we're going to use sine this time. Sine 45 degrees. So this would be 10 sine 45 degrees. As I said in example 1.2.1, there are many ways of thinking about these things. The other force, the Q component, well, that is pointing down. It's got a negative vertical component. So I'm going to put a minus here. It's going to be minus 8. Now we're currently working in the vertical direction, and this 30 degree angle is not adjacent to the vertical. It's adjacent to the horizontal. Remember, adjacent means next to. So it's not adjacent to the vertical, so therefore I'm not going to use cos, I'm going to use sine. So there we go, 10 sine 45, take away 8 sine 30. Other things that would be correct, instead of sine 45, if you wrote cos 45, that is also correct. They are the same. Instead of sine 30, you might have written cos 60. Again, that is also correct. They are the same. In the horizontal component, if you'd used sine 60 instead of cos 30, that would have been also correct. So let's simplify this. 10 sine 45 is 5 root 2. Sine 30 is a half. So this is 5 root 2, take away 4. So those are the horizontal and vertical components of the resultant. So we now have two forces that are perpendicular to each other, one horizontal and one vertical. 5 root 2 take away 4 is definitely positive, so I can draw Fy pointing upwards. And we want to find the resultant of those two forces. which I've labelled R here. I could use any letter alike. Instead of P and Q in this example, any letter could have been used. So the reason we broke them down into perpendicular components is because now we can just use Pythagoras to find the magnitude of R, or in other words, to find how long is this hypotenuse, and then we can use right angle trigonometry to find the direction. So I'm going to call this angle alpha. So let's work out the size and the direction of this resultant force. So by Pythagoras, r squared will equal fx squared plus fy squared, which when we put our values of fx and fy in and simplify it, make sure you remember to square root this. I end up getting the square root of 205.411, etc., which turns out to be 14.3. Now this is a quantity, it's a force, so it needs units, newtons, and show that we've rounded 3 significant figures. So that is the magnitude of the resultant force. So these original two forces, the 10 Newton force and the 8 Newton force, together they can provide a force of 14.3 newtons. Now what direction will that be in? So I'm going to work out the direction to the horizontal, which is alpha in my diagram. So tan alpha will be the opposite, which is fy, over the adjacent, which is fx. So 5 root 2 take 4, all divided by 5 root 2 plus 4 root 3. That's tan alpha. And then do inverse tan of that. You can give answer in degrees or radians. It doesn't matter. Just always check the question, make sure you give what it asks for. And in this case, it didn't specify, so either will do. And by doing inverse tan of this fraction, so inverse tan of this fraction here, I get 12.4 degrees to 3 significant figures. So 12.4 degrees to 3 significant figures. When you're describing a direction of a force, it's a good idea to say something like this is above the positive x-axis. The diagram helps. The fact that I've drawn a diagram over here and labelled alpha, so you can see where alpha is, but it's also worth writing it as well. So there we go. That's this example finished.